So now that we've looked at the types of measurements and the units that we can use to measure different properties of objects, let's look at two terms that we can use to describe these measurements. So the first one is accuracy. Accuracy is a measure of how close the results are to an actual or accepted value. For example, if the actual value for a measurement is 20 centimeters, and I measured the following values: 19, 21, and 20 centimeters, these results would all be considered to be accurate because they are all close to the actual value. Now, the other term I can use is precision. Precision is a measure of how close the results are to each other. We'll use the same example, so the same actual value of 20, and I can have values of, let's say, I measure 14, 0.2, 14.6, 15.1, and if you notice, these results are not accurate. They are not close to the actual value, but they are precise because all three of these values are very close in value to each other. And for those of you paying very close attention, you may have just realized I forgot something very important, my unit. So I will put in the units as well. Measurements don't mean much without the units. The other thing that you'll notice here is that the terms that I said are precise tend to have decimal points, and this is going to come into play very soon, but you tend to notice that precise measurements have more numbers after the decimal point. So we tend to consider a number with more decimals to be more precise. So now let's look at a more visual representation of what accuracy and precision actually mean. So here is an example of a bullseye. So we are throwing darts at a target, and there are 4 different things that can happen. So our goal is to hit the middle here. So on all 4 of these boards, the goal, the accepted value, what we want to hit is right in the middle of that target. In the upper left-hand corner here, we say that these results are not accurate, and the reason why they're not accurate is that the majority of them are not close to our goal. So they're not close to our target value, so they are not accurate. They are also not precise because all of our results are not close to each other. In this one, we do say it's accurate because all of our results are around our centered value. So if we averaged where these points were, we would get something close to the accepted value. They are not precise, though, again, because they are not close to each other. In this diagram, in the lower left, these are not accurate. They are not accurate because they are not close to the accepted value. But they are precise, and they are precise because all of these values are very close to each other. And lastly, in the lower right-hand corner, we have something that is accurate because all of our darts have hit the target. They're very, very close to the actual value. And they are precise because they are very close to each other.